Morning students. In the last class we talked about queues and we looked into queues in a very great detail and we understood about the various operations like when the queue is empty we define the function for conditions for checking whether the queue is empty or whether the queue is full, and we wrote the code about the NQ operation, how to add an element from the front end to the queue, that is NQ operation. And we also discussed about the DQ operation, how to get an element out of the queue from the rear end is called DQ operation. Okay, so we pretty much covered everything about queue. Now we will discuss what is the drawback of a normal queue. How a normal queue looks like. As you can see, there are positions. Suppose I will say n is 5. The size of the queue is 5. So we have index 0, 1, 2, 3, 4. Initially, front and rear both point to -1. Okay? So the queue is empty. So the condition is queue is empty now. Now what is the drawback? I am trying to make you understand. What is the problem with this normal queue and why we are moving towards circular queue? So the problem with this normal queue is, suppose you insert an element 12, 15, 18, then again you NQ an element 25, then again you NQ element 27. So now at this point rear points to this, front is here. Okay? Now suppose we want to delete. We deleted all the 4 elements. Front is here. Then we deleted this, front is here. Then we deleted this, front is here. Then we deleted this, front is here. So now the situation is somewhat like this. Now can we insert any more further? Now if we want to insert an element like 29, we want to insert it into, we want to NQ it. NQ it. 29 NQ. Can we do that? I am asking you a valid question. Can we do that? Can we NQ 29 into this queue now? The answer is no. We can't, because queue is already full. What is the condition for queue full? When is the queue full? Queue is full when real plus 1 is equal to n. If this condition is true, we say queue is full. Isn't it? Do you remember? We discussed it in just the previous class. So when real plus 1 is already n, here real is pointing where? 4. 4 plus 1 is equal to 5. It is getting true. That means queue is full. Now but you can see that man, there are 4 slots empty. We can add it there, but we cannot. We cannot add element from rear end in the queue. This is the property of the queue. What is the property of the queue? It works in FIFO order. We can delete from front end, but we can add from rear end. Okay, that is the property. So according to that property, we cannot add any element into this queue further, although we have empty slots left. Now that is the drawback of normal queue. That's why we move towards circular queue. Because we want to efficiently use the space, isn't it? There are space, but still we cannot store anything. What's the use? So that's why we go for circular queue. Now I will make you understand what is a circular queue. So circular queue is somewhat like this. You can think of it like this. We have 5 slots. 0, 1, 2, 3, 4. Let's make it 5. N is equal to 6, suppose. Total size is 6. We have 6 slots starting from 0 to index 5. This is our circular queue. What happens with circular queue is, we will take up the same scenario and check whether we can add element. Now, before previous scenario with this circular queue, let's check the overflow and underflow condition. When is queue full? When is queue full? So I am writing the function for queue full in a circular queue. In circular queue, we can think of it as circular queue like a linear queue. In circular queue, if the real end is there, after which in normal queue we cannot insert, right? But in circular queue, we can increment the real and it will point back to here. So next element if we insert here. Suppose it was 27, right? Now we want to insert 29. We cannot insert in normal queue, but we can insert in circular queue. Why? Because the next element it will be inserted in is 29 here. We can insert here and here will be pointing to here. This is how circular queue works. Next, you want to insert something 30, then you will insert and here will point to here. Front will point to here because it was pointing there only. Now, if you delete some element, suppose we want to delete element, we will delete it from the front end. So 27 will be deleted and front will point to here next. Front will next point to here. So this is how circular queue works. Now suppose you insert 38. So here will be pointing to here instead of here. So here will point to here. Suppose I delete 29. I deleted it. So it is deleted. So front will be pointing to here. Front will be pointing to here because this is the front, this is the rear. Okay, so this is how operations in circular queue takes place. So the condition is when is the queue full? When will the queue be full? Queue will be full when suppose the queue full 38, 40. The queue will be full when suppose, let's make you understand with the scenario. Let's take up the same scenario. N is equal to 0, 1, 2, 3, 4. So n is equal to 5. 0, 1, 2, 3, 4. We'll take the same scenario. But think of it as a circular queue. Here, after real, there will be nothing like there is nothing. It will be pointing to here next. Okay. After this is full, we can still, fill elements in the empty slot. That's the point of circular queue. Okay. So suppose I add element 12, 15. Front is here, rear will be here. Suppose I am filling everything 38, 99, 105. So now this is rear. Okay. Now we want to delete element. I delete something. So front is pointing to here, right? Now in normal queue can we add element? No, right? Because 4 plus 1 is 5. Rear plus 1 is n. So we cannot add. But in circular queue we can add. How we can add? Because the next element is r will be updated as r plus 1 mod n. R will be updated as r plus 1 mod n. In normal queue we just used to increment r equal to r plus 1 or we used to write r plus plus. That means r is equal to r plus 1. R is incremented by 1. But here we are doing mod operation. That means whatever the value is, it will be mod. Now suppose r is 5. So what will happen? 4 plus 1 mod n. What is it? 5 mod 5 is equal to 0. So r will be incremented to 0. So if you want to add 108, suppose you want to add 108, then you can add. So in such a case, what will happen? We add 108 and rear will be pointing to now 0. How it is pointing to 0? Because rear will be incremented at r plus 1 mod n. What is r plus 1? 4 plus 1 is 5. So 5 plus 5 mod 5 is 0. So r will be incremented as 0. 0. This is the essence of circular queue. That if there is free space, even though you are at the end of queue, still next element can be incremented in the zeroth position. Okay. Now this is empty. If you want to add further, suppose you want to add 210 to this. Suppose you want to add 210 to this. Can you add this? Of course you add. You can add. First you will increment. What is increment? R is equal to R plus 1 mod n. You will do this. What is R now? 0. So 0 plus 1 mod 5. 1 mod 5 is 1. So R will be incremented as 1. So R will be pointed to 0. And you can add any element that you want. Is the queue full now? Still it is not full. We will eventually check how we can find the queue is full. See, now if you want to further add, you can do the mod operation. So you can increment 1. What is the value? R plus 1. 1 plus 1 is 2. 2 mod 5 is 2. So R will be incremented and you can add 128. And then you can add suppose 150 you want to add. It will be incremented. Why? Because 2 plus 1 is 3. 3 mod 5 is what? 3. 3 mod 5 is 3. Now you check. Again you want to add. Can you add? No, you cannot add. So the condition for Q full is when R is equal to, when you increment the next value of R. What is the incremented value of R? R plus 1 mod n, isn't it? This is the incremented value. So if R is pointing to 3, 3 plus 1 mod n. That is 4 mod 5. 4 mod 5 is what? 4, isn't it? So if R plus 1 mod n, that is the incremented value, that is 4. If 4 is equal to front, that is if R plus 1 mod l is equal to front, then we say Q is full. Okay. If the incremented value of R is occupied, that is if it is the front, this was our front, okay, because we deleted all, it was rear and front, then we added and rear got incremented, but front was the rear only, isn't it? So if the incremented value of R is equal to front, we say Q is full. So what is the condition for Q full? If R plus 1 mod n is equal to F of front, we say Q is full. So how to check Q full? This is the function. If this case is true, then we say Q is full. Printf Q is full and return what else? Return 0. Okay. This is the function for Q full. You will note it now. See, if incremented value, if the next position after R is pointing to front, if that is the front, then we say Q is full. Okay. Similarly, when is Q empty? Q is empty when both front and rear are -1. That is same. Okay. Q is empty. Q empty. The condition for Q empty is if front equal to rear and front equal to -1 or rear equal to -1, whatever. If this condition is true, then we say that Q is empty. So this is the condition for Q empty. Return what else. If this condition is not true, then we return 0. That means Q is not empty. So these are the functions for Q full and Q empty. You may note it down. And now we will see how to dequeue an element from the queue, and then we will see how to add an element, that is NQ element into a circular queue. Okay. So in DQ operation, what we do is first we have to check whether the queue is empty or not. If it is not empty, then if it is already empty, then we cannot perform the queue. Okay. So then we have to check whether it is the only element present in the queue. If only one element is present in the queue, that is, if front is equal to R, then what we have to do? We have to get the element That is the only element from the front end, and QF will be stored in a temporary variable, and we will update front and rear to -1 -1. Okay. Now, if only one element is not present, normally there are few elements in the queue. Then what we will do usually, whenever we delete from the front, we increment the front. That's what we do. So that is what we will do here. We will take out the front element and will store it in a temporary variable, and we will increment front in normal cases. Okay. So this is the last case. So what happens in the queue is, first we have to check whether the queue is empty. If it is already empty, we cannot perform deletion. Okay. If only one element is present, then we will simply retrieve the element and will update f and r to -1 -1. Otherwise, we will simply get the element out and store it in a temporary variable and return it, and we will increment front. This is what happens in D. Now you will understand what happens, how to add element, in a queue. How to enqueue? For enqueuing, first we have to, add an element x. Suppose you want to add an element s, first we have to check whether queue is already full or not. If it is already full, we cannot add, so we have to check queue full. If queue full is true, then we cannot add. We simply printf can't add. If only no element is present, if the queue is totally empty, then what we have to do? F and R are -1. We have to keep them to 0. This is what we do. We simply increment F and R if queue is already empty. If queue is already empty, for that matter, what we write? If F is equal to R and R is equal to -1. This is the condition for empty. If this is true, then what will happen? We will increment front and rear. That is, we will bring them to 0 and we will put the element. Okay, how to put the element? Q, R will be updated, and what will be put? X will be put input. Okay, so this is what happens when no element is present and we are going to add the first element. Now, otherwise, normally what we do after addition? We will simply increment rear, isn't it? So in the third case, we will simply increment rear after adding. How to add? We will first increment rear. R is equal to R plus 1 mod n. We incremented rear. Then what will we do? We will put X in place of R. Okay. So this is the part, and the function ends. So this is the entire function for ending. We have to check whether queue is full. If it is full, we cannot further add. Otherwise, if the queue is already empty, we are going to add the first element. So for adding the first element, we have to bring F and R to 0. Okay, because they are already 1. If they are already -1, that means queue is empty and we are going to add the first element. So we put it in QR. First we have to increment R and F, and we have to put it, because front and rear should be same. If we are adding only one element into the queue, then front and rear will be pointing to the same element, because it has only one element. So in such case, we will increment it and we will assign X to queue of rear. Otherwise, we will simply increment rear and put X into rear end. Okay, we will add at the rear end. So this is what NQ is. Okay.